Let's talk a little bit about algebraic structure, shall we? So, what I have on the board over here are some English phrases that we're going to translate into algebraic expressions for the purpose of getting a sense of algebraic structure. The first one up there, 3 times the difference between a number and 5. Now let's break this thing apart. First of all, 3 times. Probably safe to say that you recognize that as a multiplication situation, 3 multiplied by 3 times. So we're for sure going to have 3 multiplied by something. But what's the something that we're multiplying by? It's 3 times the difference. Now, difference is a mathematical term that speaks of the idea of subtraction. To find a difference between 2 quantities means to find to compute a subtraction problem. So we're subtracting a number and 5. But now I want you to see the structure here. The multiplication, first of all, the 3 times, it's 3 times the difference. It's 3 times this subtraction. It's 3 times this thing that happens when you subtract a couple of numbers. It's not 3 times a single number. It's 3 times the difference between 2 numbers. Let me just focus on that difference for a minute. It's the difference between a number and 5. So if you have a number, let's say n and 5, the difference would be n minus 5. And so to communicate that we want 3 times that difference, notice we use the parentheses. If the parentheses were not there, then what it would say is you just have 3 times the number, n. You wouldn't have 3 times the difference. So in math, the parentheses just communicate for us that we're thinking about this entire difference, and then we want 3 times that entire difference. So 3 times the difference, and the difference is between a number, and they don't tell us the number, so we'll use a variable to represent that idea, the number and 5. Okay, how about this one? 4 fewer than, so probably fewer than, you're thinking about the idea of subtraction again, but fewer than what? A product. Now, product is a mathematical word that speaks of the idea of multiplication. So a product of 2 numbers means to multiply those 2 numbers. So we're 4 fewer than a product. Now, a product is a multiplication of at least 2 numbers. Let's see. What is the product between a number and 8 more than a number? So the and here kind of links together the 2 things that we're multiplying in this product. We're multiplying a number and 8 more than that number. Well, again, they don't tell us what the number is. Let's use the variable idea. And so I'll use n again. So we have a product of a number and 8 more than a number. Now again, in terms of structure, to capture that this 8 more than a number is one of the things that we're multiplying, and a number is the other thing that we're multiplying, I'm going to use the idea of parentheses to clearly communicate that the phrase is the product, the multiplication of 8 more than a number, that's one thing. So the parentheses kind of capture that idea that you have one thing, and then the number. So the product of a number, there it is, and 8 more than a number. So the 2 things are a number and 8 more than a number, and it's a product, it's a multiplication. Now, back to the beginning. 4 fewer than that. And the reason we have to kind of back up and see that last is because it starts with 4 fewer than the product. So we kind of had to figure out, well, what do they mean by this product first? Then we can backtrack and express the idea of 4 fewer than that. 4 less than that. Subtract 4 from that product. And then finally on this last one, 4 less than a quotient. So again, the idea of less than, we're 4 less than, so it's a subtraction. We want to back up 4 from wherever we were. And where were we? A quotient. And quotient is the mathematical term that tells us the result of a division. So we're 4 less than a division. And again, like product, there's got to be at least 2 things, or like difference, there's got to be at least 2 things. With quotient, there's got to be at least 2 things. What are the 2 things we're dividing? It's the quotient of twice a number, and 7. So again, there's the linking and to kind of help us to see what the quotient is between. It's between two things, this and this. And the first thing, the first and is the twice a number. So twice a number, quotient, divide by. And now that we're in algebra, we're not going to use the kind of elementary school line with 2 dots division. We're going to use the fraction idea of division. So here's the quotient of twice a number, 2 times a number. Again, some unknown number, I'll use n. 2 times a number and n, there's the quotient, and then we're 4 less than that. So again, notice we have to go back to the 4 less than at the end because of the way this thing is structured. It's 4 less than something. It's 4 less than something. And what's the something? The something is the quotient. So I have to find that quotient first and then think 4 less than that. All right. So that's sort of the, say you have an English phrase and you're trying to think about the structure, the mathematics behind it. Well, let's turn this thing around. This time I'm going to give you some mathematical expressions and we'll try to put some English understanding to them. So here's the story. I go to Sam's Club on Saturday. I went to Sam's Club and I spent some money. The amount of money I spent is given by the variable S. It's a placeholder, because if you saw my receipt, you could look to see how much money I spent at Sam's Club. So it's not a changing quantity, it's just a placeholder, an unknown quantity for you. So S is this amount of money I spent at Sam's Club on Saturday. But then I also had to go to Costco, because you know how it is. There's stuff at Costco that Sam's doesn't have, there's stuff at Sam's Costco doesn't have, so I had to go to both places. So I went to Costco and I spent C dollars. So C is the amount of money I spent at Costco. Both of these, by the way, are in dollars. So what would it mean to say S minus C? So in your mind, you have to think S represents an amount of money, the amount of money I spent at Sam's Club. C represents an amount of money, the amount of money I spent at Costco. And maybe I would, in my mind, if I'm thinking about my household budget or I'm sharing with my wife what happened, I might say something like this. I spent more money at Sam's Club than I spent at Costco. She might ask me, well, how much more did you spend? To find out how much more money I spent at Sam's Club than at Costco, I would have to subtract those two amounts to find out. So just as an example, suppose the amount of money I spent at Sam's Club was like $350, and the amount of money I spent at Costco was like $200. So the question, how much more money did you spend at Sam's Club than at Costco? To find out, I would subtract those two amounts, $350 minus $200, and see that $150 difference. I don't want to necessarily go to specific amounts here. I just want you to think in general that the idea of subtraction will allow us to find out something like this. This expression mathematically will tell me how much more money I spent at Sam's Club than Costco. Now, go down to the second one. What if I added those two amounts? What if I took the amount of money I spent at Sam's Club and added it to the amount of money I spent at Costco? What would that tell me? Again, this is not that you have to do anything. This is not a compute anything. This is not a solve anything. This is a just, what does this expression mean? If you can look at algebraic expressions and kind of get your brain thinking about what they mean, it's going to be really useful for us. So what does S plus C mean? How much money I spent at Sam's Club, how much money I spent at Costco, put them all together. It's just the total amount of money I spent that day at those two stores. So again, in terms of my household budget, in terms of my wife wants to know, well, how much money did you spend today? I could say, well, put those two amounts together, add them, and get the total amount of money spent at both stores. Now just one more. That last thing is something I just made up just to help us to think about some algebraic structure. And what I want you to think about here is I've just made a claim. S is equal to. Now remember, when we see equals, we're gonna think is the same as. In mathematics, it allows us to communicate an equivalence. So the amount of money is the same as, the amount of money spent at Sam's Club is the same as, what do I have over here? I added $50 to C. So the amount of money I spent at Sam's Club is $50 more than I spent at Costco. And then it's 3 times that. So what we could say here is the amount of money spent at Sam's Club is the same as triple 3 times 50 more than the amount spent at Costco. Or you could say it backward. The amount of money spent at Sam's Club is the same as, is equivalent to $50 more than I spent at Costco. Triple that. That's how much money I spent at Sam's Club. So again, I don't want you to necessarily have any specific values here, but just to express the ideas here. But just imagine I told you that I spent $200 at Costco. And we want to know how much you just spent at Sam's Club. Well, $200 spent at Costco, 50 more than that would be $250. Triple $250. You can check this on your calculator if you need to, but if you triple $250, you would get $750. So if this was true, and if I spent $200 at Costco, $250, triple that, I would have spent $750 at Sam's Club. That's a lot of jars of pickles. So, not saying this is true, just saying that's what this would mean structurally. But in general, for whatever amount of money I spent at Costco, 50 more than that, and triple that, that's how much money I spent at Sam's Club. Hope that helps you see English and math and how we bridge those two languages to make sense of some algebraic structure.